All right, class. So this is a review of Chapter 6 and specifically 6b, although I will review a couple elements from 6a. I'm going to do the wide gambit here, quick review. Listen, you can fast forward where you need to. Remember, the key here is polynomial functions, All right, so let's get right into it. Classifying. All right, so how do you classify a polynomial or a quadratic or linear? All right, so remember you're looking at the degree and you're looking at how many different variables. All right, so let's take a look at the degree. Look at the variable. It's a first power variable, therefore it's first degree. Anything first degree is linear. Linear, all right? Actually, I should put first here and linear out here. All right, because it's first degree, it's linear. How many different variables are there? Well, there's only an x variable, so there's only one variable. When there's one variable, it's an equation. So therefore, this is a linear equation. I don't care if the variable is an x, a y, a z. It does not matter. The fact that there's only one variable makes an equation. Second example. Again, I'm going to look at the degree first. Y is to the first power, x is to the first power. The degree is first, therefore it's linear. First degree equation, it's linear. Again, this is basic system as long as they're not multiplied together. All right, and then I'm looking at how many different variables. In this case, I have an x and a y, so there are two. Whenever there are two different variables, it is a function. Again, generally speaking, there are some exceptions. Looking at the second situation, again, I'm looking at the degree. It's the degree of the highest degree term. Now we have a second degree. Second degree. Second degrees are quadratic. Quadratic. Now, is it a quadratic equation or quadratic function? How many different variables? There's only one variable. That's an equation. Next situation. Again, I'm looking at the degree. Y is to the first power, but this squared here applies to this x. So the x is to the second power. This is a second degree. Because it's second degree, it is quadratic. And again, now I have to understand how many variables are there. There's an x variable and a y. Could be an s and a t. Could be acceleration and time, a and t. There's different, doesn't really matter what the two are. There are two different kinds of variables. Therefore, this is a function. Quadratic function. Next example, again, I'm looking at the degree. Okay, it's a third degree. Anything third degree or higher we'll call a polynomial. Third degree or higher. Polynomial. Polynomial. No O there. Polynomial. Oh, brother. It's a polynomial. And again, I'm going to look at how many different variables. There's only one variable. Polynomial equation. And you can see our last example. The degree is third or higher. This one's fifth degree. Two different variables. Polynomial function. Okay? Look, you should be able to recognize those things. That's how you do it. The key is the degree and how many different variables. First degree linear, second degree quadratic, third or higher polynomial, one variable equation, two variables function. All right, quick review of quadratics. So here's a basic quadratic, y equals ax squared. This is very, very simplistic in its thought. And so this is the base model here. And so let's suppose we had y equals 1/2 x squared. All right, remember, first thing we want to figure out, is this a max or a min? The a is positive, therefore this is a min. And what are the coordinates of the max or min point? 0, 0. All right, so we know it's a min. What's the line of symmetry? X equals 0, right? X equals the x coordinate. So we know that this is a parabola. We know it opens up because mins open up. The vertex is at 0, 0, and the line of symmetry is x equals 0. How would we graph this? XY chart. Again, because of the half, I'm going to go by 2's. I put a 2 in for the x. 2 squared is 4. 4 times a half is 2. I have a point at 0, 2. I'm sorry, at 2, 2. Because of the line of symmetry, I have a point on the other side at negative 2, 2. Go to 4. 1/2 times 4 squared. 4 squared is 16. 16 times a half is 8. And I have the point 4, 8. 4, 5, 6, 7, be right about there, and go 4 the other way. 1, 2, 3, 4. We would be there, and here is my parabola. Okay? And so we just graph that. Next situation, we can add to it now a vertical. There's a vertical transformation. All right? Vertical transformation. So y equals ax squared plus k. Now we have a vertical. We have a k value. So again, we want to go through everything, and we want to say whether this is a max or a min. And you know what? To make life easier on myself, I'm going to make this half. Half x squared minus 4. Okay, the half is positive, so it's a min. It opens up. What are the coordinates of the midpoint? H is 0. There is no h. But k, the vertical shift, is negative 4. All right, what's the line of symmetry? X equals 0. By the way, is this relatively wide, flatter, or steep? The a value, absolute value of a, is less than 1, so we call that relatively wide or flatter. So again, this would be wide, and we're doing the same thing. This would be wide or flatter. Now, I can save myself some time if I can grab this function and copy it, and then I'm going to paste it. Okay, so here's that parabola. Now, remember, the half does the width of it. So because the a in the first example is a half and the a in the second example is a half, the width's going to stay the same. So this is the exact parabola with the vertex at negative 4. And it would be right there. And again, you can go through all the rest and plot the XY chart, but you'd get that parabola right there in that location. Okay? So if you were to do this, just it's hard to get it right where I want it here electronically. But basically the idea is if you would do a value, x value of 2, you would get negative 2, etc., and there's the parabola. All right, third scenario. Here's the full-blown one. And so don't forget y equals a times the quantity x minus h, quantity squared plus k. Now this one has both a horizontal shift and a vertical shift. So again, is this a max or a min? The a value is positive, so it's a min. What are the coordinates of the vertex? Be careful here, negative 2. If you want to fit the scenario of x minus and then the h value, it must have been minus a minus 2. Do you remember that? Hope you do. Vertical shift is a 1. So this is now that parabola shifted 2 to the left and 1 right. Again, line of symmetry on this one. X equal negative 2. And again, it's still a half. Even if it were negative a half, we would call it relatively wide or flatter. So let me paste that parabola one more time. And all I need to do is move the vertex to negative 2, 1, which is right there. And there is that parabola. Okay? Now again, if you were graphing this full-born, you would say it's a min, you would say the min coordinates, you would say the line of symmetry, you would do an XY chart to get your points and solve. All right, parabolas. Don't forget them. Make sure you can read whether it's a max or a min. Make sure you can read the vertex coordinates. Make sure you can read the line of symmetry and tell it to me. And make sure you can tell me whether it's relatively wide or flatter or relatively steep or narrow. Okay, next thing we did, dividing polynomials. All right, the first example is when you're dividing by a monomial. The divisor is a monomial. So remember, this monomial must divide into every term, right, of the numerator. So my first problem is 6n cubed divided by 9n. All right, a 6 is a 2 times 3, a 9 is a 3 times 3. The 3's divide out, and n goes into n cubed once, and you leave n squared. Again, you could factor the n cubed into n times n squared. So what's my first term? 2 in the top, n squared in the top, 3 in the bottom. That's the first term. Second term, I have a negative 18 n squared over 9n. All right, we all know 9 goes into negative 18, negative 2. N squared divided by n is n. There's the second term. Last term, positive 9n divided by a 9n. Anything divided by itself is 1. There's our solution. All right, long division. All right, remember, in long division, you always take the first term, divide by the first term. We're going to figure out what goes on top. 6n cubed divided by 3n is 2n squared. And remember, I always line up my exponents, right? So this is going to be a 2n squared. So distribute 3n times 2n squared, 6n cubed, negative 2 times 2n squared, negative 4n squared. And remember, you subtract. Distribute this negative. The first term is 0. Negative 19 and positive 4 gives me a negative 15n squared. Bring down your next term. All right, front divided by front. Negative 15n squared divided by a 3n is a negative 5n. All right, front times front. 3n times negative 5 is n is negative 15n squared. Negative 2 times negative 5n is a positive 10n. But remember, subtract, distribute. Front term is 0. 31 positives and 10 negatives leaves me 21 positives. Bring down my last term. Remember, front divided by front. 21n divided by 3n is a positive 7. 3n times 7, 21n. Negative 2 times 7, negative 14. Remember, I'm subtracting. Front term is 0. 15 negatives and 14 positives leaves me 1 negative. Remember how we're going to show our remainder. I'm going to take the negative sign. I'm going to put it after the 7. I'm going to take the 1 and make it the numerator. I'm going to take the divisor and make it the denominator. There's my answer of what I get when I divide that polynomial by 3n minus 2. Next situation. What if they ask you to solve an equation or they ask you to find the zeros of a function? In both cases, you need to set them equal to 0. Therefore, I need to move this negative 10 to the other side. I'm going to add its opposite to both sides. Okay, at this point now, I got to look to factor. I got to factor this thing. Now, I always want to look to see if two binomials work. Perhaps this thing will factor into two binomials. Maybe not, but maybe. Sometimes it will, and sometimes it won't. If it does, great. If it doesn't, then I've got to go another route. All right, so actually in this one, I made a mistake here in writing this, and I want to make sure that I write it correctly because I want to illustrate something here of importance. So this is supposed to be negative 2x squared, and then it's supposed to be minus 5x equals negative 10. Okay? Sorry about that, but I want to illustrate this first concept. So now we end up with x cubed minus 2x squared minus 5x, and then add a positive 10 to both sides. Okay, so again, the first thing you want to try is factoring. So I'm going to try two binomials. Remember, the front will be factors of the front. So x squared and x. The backs will be factors of the back. Now, I know I have negatives inside, so I know it's going to be a negative times a negative. Has to be if it's going to work. And I have 1 and 10, 2 and 5. Now notice the middle term has a negative 2x squared, and the outers get multiplied. So if I had a 2 there, that would be a negative 2x squared. That means I got to put a 5 there, and notice the inners gives you the negative 5x. Oh, this thing factors. Beautiful. So remember, I'm trying to solve this. Okay, I already know one of the solutions. From this, as I set it equal to 0, I get x equal 2. There's one solution. Now the other part I have to get from here. I have a quadratic equation. I can factor this and solve it, or I can just solve the little quadratic. And so, how about this? X squared minus 5 equals 0. How do you solve quadratics? 3 ways. You can take the square root of both sides. You can factor, set it equals 0, or use the quadratic equation. Move the 5 to the other side. Take the square root of both sides, and don't forget the plus minus. X equals plus or minus the square root of 5. There are our 3 solutions. And by the way, it was a third degree fundamental theorem of algebra. We'd have up to 3. There would be 3 complex number solutions. And so we have 3 solutions. Okay, so again, whenever you're going to solve a polynomial equation, you got to set it equal to 0, factor it, and find the values of each factor. All right, second scenario. We want to find the zeros of a function that's just like solving, only it's a function. In this case, set the y variable equal to 0. Now we're at the same place. We have to factor. We have to factor to solve this thing. So we're at that same kind of scenario, only in this situation, we are looking to factor. Now, I can sit there and I can try 2 binomials, but I'm not going to find it with 2 binomials. Okay, you can try, but you don't get what you got there. It just doesn't work. You're not going to get a binomial times a binomial. So I've got to go another route. Remember the remainder theorem. I have to find a factor. I'm going to use the fact that I have a -2, and a 2 is nice. So here are my possible factors. X minus 1 could be a factor. X plus 1 could be a factor. X minus 2 could be a factor. X plus 2 could be a factor. Okay, so those are my possibilities. So I have to begin to figure out what I'm going to try. All right, I'm going to try the x plus 1. I'm going to try the x plus 1. And remember, with the remainder theorem, trying an x plus 1 means I'm going to do f of -1. I'm going to put it into the function. So everywhere where the variable is, I'm going to try a -1 to see if x plus 1 is a factor. Okay, first term, -1 cubed is a -1 times 2 is a -2. Second term, -1 squared is 1 times -2 is a -2. Third term, -5 times -1 is a +5 minus 2. What in the world happened? I don't like it. It was supposed to work. What did I do? That is absolutely correct. Oh, brother. This is supposed to be just x squared. It's what happens when you go fast and you want to make reviews for your students. Sorry, guys. All right, it's supposed to be 1, and therefore this is -1. -2, -1 is -3, and 2 more, -5, and sure enough, we get 0. All right, sorry about that. So that should have been 2x cubed minus x squared minus 5x minus 2. Same procedure again, we would have tried to figure out. And so we just found out x plus 1 is a factor. All right, remember, I'm trying to find the zeros. I've got to factor this thing. So I now have one factor, and now I have to do long division. 2x cubed minus x squared minus 5x minus 2 to try to then find what this factor times what gives you the original polynomial. All right, so again, front divided by front. 2 cubed divided by x, and that is a 2x squared. X times 2, 2x cubed. 1 times 2x, 2x squared. Remember, I'm subtracting. Gives me a -3x squared. Bring down the -5x. Front divided by front. That's a -3x. -3x squared. Minus 3x. Remember, I'm subtracting. So that's a -2x. Bring down the -2. Front divided by front. X goes into -2x, -2 times. x times negative 2, negative 2x, 1 times negative 2, negative 2, and sure enough I get 0. And remember, we knew that by using the remainder theorem. So here's where I'm at. I have this times this equals the 0. I already know 1, 0 of the function. X equal negative 1, that's a 0th function. I now need to try to factor this, see if I can figure out the other zeros. If I can't factor it, what would I do? I would use the quadratic equation. Let's see if it factors. 2x and x are from the front, right? From the back, I have a negative 2, and remember, I'm after that negative 3x in the middle. All right, if I put a 2 here, that's a 4. If it were negative, that would give me a negative 4. And a positive 1 would give me that negative 3. Hey, there it is. Okay, so remember, 2x plus 1 equals 0. Move the 1 to the other side, divide by 2. X equal negative a half, second 0. And from this one, x equal 2, third 0. So 1, 1, 2, 3, 3 zeros. And by the way, if I was going to graph this, I would then say, okay, I got a 0 there, 0 there, 0 there, and I'd go from there. I'll show you that at the end. Hey, before I get off the idea of zeros and solving, don't forget about conjugates. Don't forget about conjugates. So with polynomials, whenever you have a conjugate, whenever you have irrational or complex, you have its conjugate. For example, if you had a 0 of 5 minus the square root of 2, you also know you have 5 plus the square root of 2, its conjugate. If you had irrational of negative square root of 7, you know you have its conjugate, positive square root of 7. If you have a 2i, you know you have its conjugate, negative 2i. If you have a 3, let's go negative 3 plus 7i, you know you have its conjugate, negative 3 minus 7i. And that's an important factor, and that really helps you in a lot of different scenarios if you understand the aspects of the conjugates. Okay, let's get rolling. Transformations here. All right, so I'm going to graph y equals x cubed, xy chart. All right. By the way, if I factored this, I'd find out that I have a 0 of x equals 0 because x cubed is x times x times x. Okay, so I got a 0 of x equals 0. I'm going to do negative 1. Negative 1 cubed is negative 1. All right, negative 1, negative 1. I'm going to do negative 2. Negative 2 cubed is negative 8. 6, 7, 8, right there. Beautiful. I'm going to do 1. 1 cubed is 1. I'm going to do 2. 2 cubed is 8. 6, 7, 8, right about there. Okay, here's my function. Basically like that. All right? Now, let's transform it. We grab it and copy it. Okay, so what happens then if all of a sudden they give you this? Y equals negative x cubed. All right, remember, odd power, it's going to start and finish in opposite directions, but in negative, it's going to end up in the negative direction. So this is basically this function flipped around. Now, I'm not going to take the time to do it, but it would be like this, right? It's that function reversed, okay? All right, the negative, and it's going to end up negative, and because it's an odd power, it's got to start and end differently, so it would go like that. Okay, what else? Let's get rid of that. What if we had y equals the quantity x minus 2 quantity cubed? All right, so on this one, what we have is we have a transformation of 2 left. So here would be this function. You know what I need? I need that point. I need this vertex. Let me do it out here. I need this vertex here. I think it's about there. Let me see if I can catch this all together. Group it. Okay, so in this situation, this is that exact function 2 to the left. And there it is right there. What if all of a sudden I had a plus 1? Well, now it's not only 2 left, it's 1. It is 1 up, right? So now not only go 2 to, so I'm here, here's the original, go 2 to the left and go 1 up, and I'm right there, right? You know, again, what if I had this function y equals x plus 3 quantity cubed minus 4? Okay, this is telling me, oh, stink, man. I'm going too fast. My bad. This is too right. Oh, no, I'm confusing you guys. Oh, I'm sorry, going too fast. This is 2 to the right and 1 up. Man, oh, man. That's what happens when you go fast. Haste makes mistakes, and I'm trying to go fast for you guys. And I don't want to make it worse. So let me slow down and say again. Remember, this is x minus h, quantity cubed. You read the h after a minus sign. Therefore, the h is 2, positive 2, and that's 2 to the right. In this second scenario, now you read the h after a negative. It must be a negative 3, and so that is 3 left. This is negative, and this is down 4. So now we're going to take the basic function. We're going to go 3 left, and we're going to go down 4. And there's that function. 3 left and down 4. Okay, transforming the function. Do one last quick one here. What if you simply had no h value? Well, there's no h, but there's a k. We're up 2, right? Take your basic function and go up 2. All right, you need to know that for your test, and I hope that you'll review your notes on all those transformations and also how to read the power, how to read the power of the function and all of that. Okay, to know, remember, even power, it starts and ends the same way for the lead term. Even power starts and finishes the same. Odd power starts and finishes opposite. Positive lead term always finishes to positive infinity. Negative lead term always finishes to negative infinity. All right, last thing. Let's suppose we're asked to graph this polynomial. All right, so here we got a polynomial, and we got to graph it. Full-blown problem. In this full-blown problem, we would have to begin to try to figure out some factors. I'm looking at my -4 and I'm looking at my -3, and I'm starting to think of, okay, so what are my possible factors? So, you know, again, x plus 1, x minus 1, x plus 2, x minus 2, x plus 4, x minus 4. You don't have to list them all. I'm just trying to show you all the possibilities. And by the way, with that 3, right, it could end up being 3x plus 2, 3x minus 2, 3x plus 4, 3x minus 4. Okay, I know I did that fast. Those are the possibilities. And again, you're going to go through with the remainder theorem and start trying to find a zero remainder. Now, I will tell you that if you would try the x minus 1, putting in f of 1, it would work. If you would try the the x plus 1, putting in -1, it would work. If you tried the x minus 2, putting in positive 2, it would work. And in actuality, if you put in the 3x minus 2, those 3 would work. Because basically, this is how this thing ends up. If you were to factor it, you end up with negative 3n minus 2 times n plus 1 times an n minus 2. So again, you'd have to go through the full procedure. You have to start checking to see which gives you a zero remainder. When you get that one factor, let's suppose you got the x plus 1, you then have to do long division, and then you'd have to try to factor what's left. What's left would factor into this and this if you factor out a -1 out of the front. Okay? That gives us zeros of 2/3, -1, and 2. 2/3, -1, and 2. So, graph those first. -1, 2/3, right about there, and 2, right about there. Remember, your zero started. Now, by the way, this is odd, so it's going to start and end opposite. And this is negative, so it's got to end. It's got to end down, so it's got to start up. This has to be an up-down. I'm expecting this. You should expect it by reading the lead term. All right, is up-down. XY chart. Remember, I need a value to the left of my first zero, so I'm going to do -2. I can put it in the original function, or I could put it into the factors of the function. I'm going to put in the factors. It's a little bit easier. Okay, -6, -2 is a -8, is a -1, there's a -4. -1 times -8 is +8 times 1 is -8 times 4. So this is a positive 32, right? Hey, this starts up just like I expected. Positive 32. Awesome. All right, I got to find a value between my zeros. So I'm going to go with 0. 0 is nice. So everywhere where the variable is, I'm going to put in 0. That's easiest in the original because it's going to wipe out every term except this -4. So that's a -4. On this scale, it's about there, right? Now, on this one, I'm just going to go with the 1. It is between the two zeros. So again, everywhere where the variable is, I'll put in a 1. This one is a 1. This is a 2. This is a -1. -1 times 2 is a -2. -2 times -1 is a +2. All right, so x value of 1 gives you y value of 2, so that's not very high. Somewhere about in there. Probably goes a little higher. And then I got to do 3, right? I got to go to the right of our last 0. And so I'll do that one in black, do a 3. And again, I think it's easier off a factored form. 3 times 3 minus 2. This is a 3 plus 1, and this is a 3 minus 2. 9 minus 2, that's a 7. 3 and 1 is 4, and that's a 1. So -7 times 4 is a -28 times 1 is a -28. And so we end up -28 right there. Let's go ahead and connect the dots. So we're going like this. And sure enough, we get what we expected, and up, down. We have up to 3 zeros. We do have 3. We have up to 4 directions or 3 directional changes. And indeed, we do 1, 2, 3. I'm sorry, up to 3 directions, 2 directional changes. And indeed, we do. All right. I know I went quickly, had a few mistakes in there. Sorry about that. But look, go back and review. Fast forward to the parts you really need. Don't neglect your notes. Don't neglect your previous quizzes. So look at your quizzes, look at your notes, here's some review, and hopefully you'll be ready for your test the first day we're back to school and have first hour. All right, have a great day.